Thank you very much. Right, good afternoon, everyone. Well, presuming it is afternoon for most people. As Matt said, my name's Adrian Winckles, and I'm talking about web application Honeypot threat intelligence. So, just a bit about myself. Yeah, I'm the director of the Cybersecurity and Networking Research Group at Anglia Ruskin University in Cambridge, and yes, with the other university, not the big one. And yeah, to answer Matt's question, I've been around OWASP since about 2011, 2012. And my first AppSec conference was Dublin, one of those years. Yeah, I'm an OWASP Europe board member, and I'm project leader for a couple of different projects. The Web Honeypot project I'm talking about today, and the application security curriculum project I talked about the hour previous to this one. And I also sit on a number of other industry forums, which probably aren't relevant here. So, first question I'll pose is, why OWASP Web Honeypots? Well, a lot of the stuff that we're talking about for AppSec USA today is going to be around, obviously, web applications, secure HTTP. Remember, we also talk about cloud, but many of the SaaS offerings we have, of course, are fronted by web applications. If you think about organizations like CADA, the Center for Applied Internet Data Analysis, web still accounts for about 85% of total internet traffic. So a lot of what you want from threat intelligence is going to be web related. Of course, we've moved on from the simple stateless HTTP get and response. Generally, our web architectures are becoming more complicated. That also means that we have complexity. If we have complexity, we're going to have complicated attacks. Also means that even if there are attacks that only work on a tiny percentage of systems, they are still valuable, because the vulnerability that that tiny percentage throws up is going to be exploitable on a number of systems, probably for large organizations with quite devastating financial, reputational, loss of business, all kinds of different aspects. So that the point I guess I'm making is, we have a complexity problem. We have lots of different technologies in our dev environments, not just for the web application, but we have mobile, we have voice, we have web services, we have semantic web, we have all the privacy and security considerations, and we build on top of a stack. We still have XQuery, XPath, DOM, we have web architecture principles, we still have the URL, HTTP, and it's all one web, and it's all sitting on the same internet. We have a wide diversity of attacks. We have attacker on a server, we have server-side attacks, we have client-side attacks, we have attacks on client-side via server-side, we have attacks on server-side via server-side, we have attacks on intermediary, we have proxy systems. The complexity goes on. Now, one of the problems we've had typically with web applications is that we consider the web server to be trusted, but we still give that trust to our backend database. Hence the reason that things like SQL injection attacks can be propagated through a URL or through form entry and attacking the SQL interpreter behind it. And we open the port, we open port 80, port 443, or whatever proprietary port we happen to be using. And our normal firewalls and all these sort of things don't generally detect the attacks because the port's open. This has obviously led to the use of the WAF, the Web Application Firewall, because it is designed to identify to block malicious traffic requests. It's going to look inside the HTTP request or the HTTP response, and will be sit there between the user requests and the web application server. So the WAF, for any organization that is seriously utilizing web applications, is part of their Swiss cheese. It's one of their layers of security, their defense in depth, but is something that we can perhaps utilize to give us more sort of threat intelligence. So can we use a WAF as a honeypot or a probe? Now, the beauty of a WAF is they can be placed in several different places in a network. They can be in line, they can be out of line. Very often, they're on the web server. And that gives us potentially a use for our honeypot. They might use different technologies. They might be signature-based or heuristics-based, often driven by PCI DSS requirements. Again, it's an approved security control. But sometimes you think, well, isn't an IDS a similar device? Yes and no. An IDS looks at all traffic that go past the wire. A WAF is looking specifically at web traffic. And the traditional way is putting a WAF in front of your web application server. So there's not actually an application for an IDS to protect. An IDS is more generalistic. Now, if you can combine the WAF with a web application or web server so that your attacker, the person you're trying to deceive into thinking that you've got something real that you want them to attack, that web server, that web application server can have the WAF attached to it. So it's just something to think about. Obviously, one of the difficult areas when we talked about any sort of firewall is having to write the rules yourself. Writing effective rules for firewalls, for IDSs, for anything like that is hard work, and people like to have a standard base to start from. This is sort of where OWASP CRS comes in, core rule set, because the main open source web application firewall is mod security. Again, it's almost been around 20 years. Again, I think we're currently on version 2.9.1. That might be slightly out of date. Version 3 is beckoning. Mod security is often bundled with Apache. Works with Nginx, as far as I'm aware. But the fact that we have the core rule set, which is on version 3 point something at the moment, again, that was developed back in 2009, which basically, this is a set of generic rules for mod security users. We have a standard set of rules for blocking different types of web-related attack in sort of different modes. Then it's essentially a set of plug-and-play set of WAF rules. You can choose your mode of operation, standard versus anomaly scoring, and there's all kinds of detection categories protocol validation, generic attack signatures, known vulnerability signatures, Trojan backdoors, denial of service, a whole range. But it's a good starting point for protecting web applications. And CRS is a flagship OWASP project as well. Now, it can have an IDS, IPS type mode with self-contained rules. Again, those rules are stateless. There's no intelligence between the rules. It's easy for a user to understand. Again, not optimal from a rules management perspective, not optimal from a security perspective. But it can have a standard mode. It can log event data to Apache's error log, as well as Mod Security's own audit log. And the important thing is Mod Security can push out events. Both it has a process called mlogc, which can push them out as HTTP or as JSON. If you really want to do something powerful, you can use a correlated mode. So basic rules are considered reference events. They don't log the Apache log. If you use correlation rules in the logging phase, you analyze both inbound and outbound events, and you can generate special events that you can push out. So there's a correlation conf for CRS. Now, why is all this important? Well, we've already said it's not really the same as an IDS. We're not looking at everything, we're just looking at web traffic. We can put a WAF essentially in front of a web server. Now, in theory, we could put a blank Apache server sitting there with no content on it at all. And the WAF will pick up all those automated scanning techniques that seem to fill the internet continually. If you ever look down your web logs, you see the automated scanning techniques looking for PHP, my admin, and all those sort of wonderful applications or backdoors that you might consider in. But what would happen if you could add some fake content to that web server and use the WAF rules as a way of gaining threat intelligence? So this is where it sort of has led to what we're trying to do with this project. What we're trying to do is pick up real-time, detailed web application attack data and generate threat reports to the community. Now, this isn't new. This is relaunched from an earlier version of an earlier WASC Spider Labs TrustWave project. And there's a reason when I picked up this project that it has sort of half died, not from the mod security point of view, but more from the admin console point of view, and I'll come on to that in a minute. So this is what the original project looked like. It was essentially distribute a standard OVA, mod security, Apache VM into data centers, into cloud environments, and they would all report back to a mod security console, and you would be able to use analysis on that console to pull the threat intelligence out. That was the general idea. And as a concept, that's pretty good. The problem is the console that collects all the probe's output. The older event consoles were effectively broken open source projects. When I first took the project over, I looked at 3 or 4 different mod security consoles. Every single one was broken because they hadn't been touched in about in some cases 6 or 7 years as open source projects. They've got to a certain point and there was no active development on them, which is again is an issue with open source projects. If there's no one actively supporting them or working on them, they tend to fall by the wayside and die. So that meant starting again. Also, using OVAs as a deployment mechanism into data centers is fine. It's still an approach we'd use, but maybe we need to be thinking about other deployment options, containerization, Docker, for example. And before a lot of potential threat data could be collected, but it wasn't put into any sort of sharing platform. There was no threat intelligence system used. And we're thinking about something like MISP, for example. So proof of concept layout, slightly different that we had before. And the proof of concept works in a Docker format. We still have our web client coming in, which attack a web server. That web server is an Apache server with core rule set, mod security. It generates effectively events based on that attack, and anything that's matched against CRS rules. We're also looking at if we can put what we call honey traps in there as well. So it uses the mod security audit logs. Those audit logs are pushed out from mod security. They can be pushed out as HTTP or they can be pushed out as JSON. What we've done now is rather than taking them out as HTTP, we've pushed them out as JSON and we've pushed them into essentially Elasticsearch. So we're using Logstash and Kibana, potentially for some visualization. And as part of the proof of concept, we're then pushing the attack and honey trap information into a MISP threat sharing system. So that potentially means the attack information can be shared with the community, so we can generate the threat intelligence there. So what we want to do is make the system a little bit more, in quotes, intelligent, or ensure a bit more, see the word entrapment, is the wrong word to use, but we have this idea of a honey trap. So we can gather information about the attacker. So we want to lure the attacker with some bait, identify the attacker from his or her actions, and gather information about the attacker from the logs. So rather than just the old version of the OWASP project had an Apache web server with no content. So it would pick up the scans, but not necessarily lure a more semi-automated or manual attacker in and gain information. So in terms of honey traps, what we built into our proof of concept was 5 different bits of bait, if you like. Adding fake listing ports. If the web client is trying to access those fake ports, it will be tagged as malicious. Maybe adding a fake entry in robots.txt file. Again, if the restricted location is accessed, it'll be tagged as malicious. We'll add fake HTML comments. And if the attacker accesses the debugging information from HTML comments, we'll mark it as malicious. We'll add fake hidden form fields. So if the attacker manipulates those hidden form fields set by the server, we'll tag it as malicious. And we'll add fake cookie data. And if those fake cookies are manipulated, we'll tag them as malicious. So what do they look like? So when it comes into Kibana, for example, we can get a honey trap alert, traffic received on a fake port. and then we can push that through into MISP as threat intelligence. We can add a fake entry in robots.txt, and we can say it's a honey trap alert, disallowed robots.txt entry access. Again, we can push that through into MISP. We can look when we've added fake HTML comments again, got it in Kibana. We can then push that through into MISP. We can add a fake hidden form field, and if that's been manipulated, that can be pushed through as before. And the same with fake cookie data can also be picked up and pushed through. And again, we'll start to get some MISP output with which we can then push out into other threat intelligence formats to share with other providers. Again, this is just proof of concept at the moment. So what we set out to do was a proof of concept to understand how we could have mod security based honeypots and probes to interact with a receiving console. Because the old console wasn't working, we could develop a new one, which we've done. So we've still got the old VM image that still works, but we've got a Docker-based test solution, so we can store the log, and we want to work with multiple probes. So we've done multiple Docker. We did some work to evaluate console options to look at the threat data before there was things like the mod security audit console, Waffle, Fluent, and there were some bespoke scripts for single and multiple probes. And the scripts worked, but the applications didn't. So really from a restarting or rebooting the project point of view, those tools were, unless we were going to start and jump on those projects for development again, it's just so I think that's where we'll start using some of the Elasticsearch type tools to do what we want. We looked at the mechanism because some of the old scripts were converting and pushing them into MySQL databases. That wasn't really needed for our proof of concept. So he said, okay, we don't want to convert from MySQL to JSON because there's a mechanism in mod security and mlogc that will take that log output and push it into JSON rather than HTTP only. And one of our other big requirements was we need a mechanism to take that audit log output. If we push it straight into Elasticsearch, we can use things like Logstash, Kibana to visualize the data. I think visualizing the data is one of the sort of important first steps, really. So it's not just manipulating the data, visualizing the data with things like Kibana. We need the output into some sort of threat intelligence format, possibly sticks. So that's where something like MISP can possibly help us, at least the sharing of the threat data coming from the honeypots. We can then probably make it more easier to export, import in sticks or taxi formats. But we may need to look at the use of concurrent logs in a format that MISP can deal with. Other possible alternatives, again, I haven't particularly looked in any detail at this yet, but I know there's an mlogc next generation for log transfer. That might be a consideration at some point. We need to look at a new VM honeypot role based on CRS3 and above. Actual other derivatives might be small footprint honeypots or probe formats. Again, utilising Docker or other containers, maybe a Raspberry Pi version. And fundamentally, this becomes potentially a big data problem. So we probably need a machine learning approach to be able to handle that, and especially to be able to automatically update the rule set being used in the probe based on threat intelligence received. So almost some sort of adaptive technology for the probes based on what's been received so far, and to automatically update when new rules are added to CRS as well. So proposed next stages, I guess there are 4 big bits of work that we can be looking at. One of them is what I call data massage. So forwarding the output from MISP into an intelligence format, whether that's sticks or taxi, so that you can share it. So it's not all on just the MISP platform, but could be sent into other systems, or more put into more friendly format depending on what's required. Big piece of work, because at the moment, obviously, all we've done is a proof of concept, is develop what we call a probe management solution to manage multiple probes or honeypots, update the configurations, change the CRS that's uploaded to them, those sorts of things. And to an extent, actually be able to manage, because the idea is we want these deployed in various data centers, other key locations. We'll talk a bit more about the probe management scenario in a minute, because there's other developments that might be useful. There's obviously the format development, as well as looking at more of the honey trap arguments. One of the other bits of work we experimented with was, can we, into the web server element, put something like a buggy content management solution, WordPress, Drupal, things like that. And we can start looking at keep an OVA version, a Docker version, a physical plug-in forget Raspberry Pi type device. But there's all those sort of format developments to talk about. And as I mentioned before, the machine learning enabled rule set updating. And I think my co-project leader, Phillips University in Uruguay, has done some work on that area, which we'll want to look at as well. So I guess the big bit of work that we still we want to embark on is developing the probe management, so we can manage probes, honeypots, either as VMs or these small footprint devices, or as Docker, but that we have a large number out there. So whether we want to do version upgrades, enhance capabilities, change the web server content, or whether we want to retire honeypots, there's a whole range of capabilities, but we need that probe management solution, whether it be via API, whether it be script-based, pull or push. Done some initial talks. I know the special projects director at Shadow Server, who house a large amount of threat intelligence gathering probes for different organizations. So that may be an opening that we can pursue. So there's quite a few, and this makes a lot of number of projects that are useful for things like Google Summer of Code, for example, for students to help work on. And we've had several instances so far that have helped us with the proof of concept solution up to now. In terms of further information, we have a GitHub repository we have our OWASP project pages, and we have the OWASP Slack channel. Please have a look, join. And obviously, if you have, if you want to take part, you have some ideas or critical feedback, please drop me a line. It's my Twitter handle, my email address. Yeah, I'm interested in any comments anyone may have, or how we're taking forward.